have learned what is FEM, are FEA and FEM different, advantages of FEA, FEM, discretization of a problem, why do we carry out meshing, what is degree of freedom, element shape characteristics, and the 10 questions you should be able to answer. In session 3, we will learn when to use 1D elements, degree of freedoms in HyperMesh, type of 1D elements, CAE process, and 1D analysis formula. First, we are going to start with when to use 1D elements. So 1D element should be used when one of the dimension is very large in comparison to the other two dimensions. Here the element shape is a line. The additional data from the user is the remaining two dimensions, that is the cross section. Element types, there are different element types like rod, bar, beam, etc. Practical applications, long shafts, beams, columns, etc. Now, how to define degree of freedoms in HyperMesh? In HyperMesh, every degree of freedom has a specific name. For example, X translation is called as DOF1. Similarly, Y translation is called as DOF2, Z translation as DOF3. Now X rotation is called as DOF4, Y rotation DOF5, and Z rotation DOF6. So HyperMesh will give you DOF1 through 6 as an option. Next, we will talk about the types of 1D element. Here we are going to discuss 3 types of 1D element: rod, bar, and beam. So rod element supports tension, compression, or torque loadings. It does not support bending. Bar element supports all 6 degrees of freedom, that is all type of loadings, applicable only for symmetric cross sections. Symmetric cross sections as in a circle or a rectangular or a square. Now beam is same as bar but also supports unsymmetric cross sections. For example, it supports circle, which is symmetric, as well as an L section, which is unsymmetric. Now we will talk about the CAE process. So in CAE process, first we start with pre-processing. Under pre-processing, we perform all the activities like geometry, which means either geometry creation or editing the geometry. Next is the meshing part, where we create elements and nodes. Then material define, property define, loading conditions, type of analysis, etc. Basically defining everything before clicking on solve comes under pre-processing. Now HyperMesh is a preprocessor. If you are familiar with ANSYS, in ANSYS we use mechanical or design modeler as a preprocessor. Before clicking on solve, everything that you do is pre-processing. Now once you click on solve, then starts the second process, which is solver. Now there are different solvers. For example, in HyperWorks there are OptiStruct, Tridios, etc. There are different solvers. In case of ANSYS, there is MHPCLL solver. Once the problem is solved, then comes the third process, which is called as post-processing. Now in post-processing, we visualize the results, like view the contour of stress, strain, displacement, etc. View the plots, view the animations, etc. Now in HyperWorks, HyperView is used as a post-processor, and in ANSYS, mechanical is used as a post-processor. So this is the CAE process. Now we are going to discuss about the 1D meshing formula. For most of the linear static 1D analysis, we can use the formula as MHPCLL. Here, M represents the material collector, H represents the HyperBeam, P represents the property collector, C represents the component collector, L stands for load collector, and the last L stands for load step. Now, in the next session, we are going to use this formula to solve a problem. So this is it for this session. Thanks a lot for attending session 3. In session 4, we are going to cover a problem statement on a 1D rod element.